You're watching Access Minnesota. Here's Jim Dubois.
Now here's our conversation with smart grid expert and University of Minnesota professor Massoud Amin. Massoud Amin is a professor of electrical and computer engineering at the University of Minnesota. He is also director of the Technological Leadership Institute at the university. Professor Amin, welcome to Access Minnesota.
Thank you, Mr. Dubois. Delighted to be here.
On June 21st, a massive storm blew through Minnesota, impacting particularly hard the Twin Cities area. Here in the Twin Cities and in the surrounding areas, about 610,000 people lost power. It was a powerful storm, strong winds, a lot of tree damage. Tell us about the power outages that resulted. Were these at all preventable, or was the storm just so great that it overwhelmed the system?
The most recent storm was really unusual, very unusual. There was a combination of factors that contributed to the massive number of customers without electricity. The ground was so saturated that large trees fell, when most of the case is tree branches that fall and not the whole trees. So the combination of strong winds combined with saturated ground and having large trees that we like very much, but unfortunately those two factors pushed many of these large trees over. And living close to Dean Parkway and Lake Calhoun, I saw firsthand whole trees that had fallen on cars and destruction of not just the system, but corridors that needed to be cleared and the electricity be brought back. This is highly unusual in Minnesota. Although weather, especially trees, are the #1 root cause, and Excel has a tree trimming program which has been on track.
With such a massive power outage affecting some 610,000 people, would it have even been reasonable to expect a speedy restoration of power? As it was, power did come back fairly quickly to some people, but others were out of power until even Tuesday or Wednesday of that week. Given the extent of the damage, how would you characterize the efforts to restore power?
They did a great job. My hat is off to 14 states, about 20 utilities, that more than 1,000 people came, crews, and they restored power. What they do, they have a schedule. They try to bring electricity up to the majority the fastest way they can. And then, unfortunately, there are usually, you can cover 90%, 95%, but there are some remaining ones. If we think about the distribution system, no pun intended, it looks like a tree. So many of those end branches in the network, we have a harder time repairing the corridors along the way and getting to the end points. So all in all, they did a great job. Whenever we have a physical destruction of any of the electricity infrastructure, such as Hurricane Sandy, Katrina, Charlie, it typically takes, for such a massive storms down in the coast or on the East Coast, takes minimum of 10 to 15 days to erect a distribution system back up. Fortunately, in the Twin Cities, the extent of the damage was not as destructive, so they could restore it much faster. But whenever there's such a massive assault on infrastructure, it's going to take crews on the ground to restore the system, to rebuild parts of the system. What we can do, we can harden some of the infrastructure, we can bury some of it judiciously underground. However, the cost of that is 3 to 10 times more to bury that underground. And utilities, including Excel, move at the speed of the market. They look at the return on investment and how long it's going to be to recover the cost. Second part we can do, not only make it stronger or underground, but we can make it smarter. We can put the oversight, a lot more better sensors, secure communication, and automation to localize only the outages to the areas that are physically damaged as opposed to the wider region.
Professor Amin, you are a big proponent of the smart grid, the so-called self-healing grid. If such a system had been in place for the June 21st storm, how would that have ameliorated the power outage situation?
Smart grid, in every assessment that I've had the privilege of doing, or Department of Energy or the Electric Power Research Institute or utilities, there are more than 99 utilities across the country that are doing projects in the area of smart grid. It reduces outages by 1 order of magnitude. How it does it? By 3 primary functions that smart grid enables. First of all, smart grid that I've had the privilege of proposing and working on and funding effort in that area in my past work began 15 and a half years ago. The vision of that I proposed at the time was the overlay of sensors, better sensors to know what's going on, better, more secure, with security built in as part of design, as part of chips and communication protocol we put in, faster communication of what's going on, and then better automation, faster automation. Similar, the background for that came from combat, came from the work I had done for Department of Defense on saving an F-15 fighter plane that had a missing wing during flight. There was a middle collision, and how to save the aircraft and the pilot. Grew to squadron of aircraft. If one aircraft goes down, two go down, three go down, can you keep the mission effectiveness? Then became battlefield management during 85 to 1997. So the idea was, what kind of sensors, what measurements do we need to have full situational awareness, to know what's going on? How do we turn that quickly into actionable intelligence? Third, what do we do about it? Same ideas that I developed for our nation's DoD, I used to transfer those same ideas to the utilities and critical infrastructure, including electric power, oil and gas communication. Fast, real-time measurement, secure measurement and secure communication of what's going on. Secondly, doing dynamic risk assessment, knowing what's the highest, biggest, if you will, pinch point in the system, what's the biggest potential Achilles heel. Third, localizing and enabling a rapid restoration if the disturbance occurs. In all the work we have seen, it would reduce outages by at least one order of magnitude. So let's say instead of 1 million people being affected in an outage, it typically reduces to 60 or 70,000 people along the corridor that is actually physical damage done. But it's going to require not only better sensors, but technology to isolate, technology to quickly reconfigure the system within less than a second, and we have the technology. The question is not the technology, it's a question of money, policy, and leadership that we can dig into as you see fit.
So the smart self-healing grid will have an environmental or a green component to it. You mentioned wind energy. Will we be looking also at perhaps some energy from solar sources?
Yes, sir. It's very much location specific. There are two aspects to it. First of all, smart grid would reduce CO2 emissions by 12 to 18% by 2030. The vision that I share with you is a 15 to 20-year vision, and it needs patient investment in the infrastructure, and the benefits far exceed the cost of that.
Climatologists predict we will see more unstable weather patterns, producing stronger storms and potentially more power outages. Implementing smart grid technology could help prevent large-scale blackouts, but there is a cost to updating our infrastructure. When Access Minnesota returns, Dr. Amin explains some of the political hurdles facing smart grid technology.
Access Minnesota will return after these messages.